All right, today we're doing a real deep dive into the hidden technology that basically powers all of US trade. This is the story of the code behind the tariff, a system that has evolved from, handwritten books all the way to the cloud, and the absolutely incredible challenges it faced along the way.
Think about this for a second. Every single time you buy a phone, a shirt, a bicycle, maybe a bag of coffee, you're interacting with a system that's older than the income tax. It's a system that's been held together over the years by everything from handwritten ledgers to 1980s mainframes, and even a last-minute hack that pretty much saved the day.
So the journey here, it spans over 2 whole centuries. It kicks off way back in 1789 with simple handwritten ledgers. Then boom, 1984, it makes this huge leap into the digital age with a COBOL mainframe. By 2016, it's become this kind of strange hybrid of old and new, before finally, just last year in 2023, becoming completely cloud native. This timeline really sets up the central conflict. How do you possibly run a 21st century trade war on 40-year-old code?
Okay, so let's start at the beginning. Our story really begins with an analog foundation, one that lasted from the birth of the nation all the way up until the dawn of the personal computer era.
For almost 200 years, the U.S. Customs Service operated without any kind of digital database. You had customs officers literally just looking at cargo, then looking it up in a big book. The system they used was called the TSUS. Now the problem? It was a completely proprietary, US-only system. This meant a shipment classified one way in Europe would be classified totally differently in the US, which, as you can imagine, led to constant disputes, delays, and just bad data all around.
So to fix this mess, in 1989, the U.S. undertook this massive data migration. They moved from their own TSUS to the new Harmonized Tariff Schedule, or HTS. This was the system's first really great leap. For the first time, the U.S. system was speaking the same language as the rest of the world, aligning its product codes with a global standard. It was a huge move from isolation to what you might call digital harmony.
And that brings us to our next chapter, the COBOL Fortress. This is where U.S. trade really, truly enters the digital age, built on the back of 1980s technology. So in 1984, the government launched ACS, the Automated Commercial System. This slide, it's like a perfect snapshot of that big iron tech stack. You've got IBM mainframes, it's all powered by COBOL, and it's using these simple text-based data structures called flat files. Now, this system was an absolute workhorse, don't get me wrong. It processed incredible volumes of trade. But it was also a fortress. Unbelievably rigid, processing data in these big overnight batches, and it was extremely difficult to change anything. And this number, wow, this just perfectly illustrates the scale we're talking about. Over its lifetime, the ACS codebase grew to 3.9 million lines of COBOL. Let that sink in. On one hand, that number represents incredible stability. But on the other, it's a monumental pile of technical debt. Every single line of that code, written back in the Reagan administration, was just another anchor holding the whole system in the past.
Which brings us to the dramatic climax of our story, the Chapter 99 hack. This is the moment where modern geopolitical pressure smashes right into 1980s infrastructure.
By 2016, a new, modern, web-based system called ACE was basically put on top of the old mainframe. So now, importers had a nice, clean user interface and modern APIs. But look at this table. All the critical financial stuff, the billing, the collections, it all still ran on that 1984 ACS mainframe. The system was literally split in two, a modern face with a legacy heart. And then the trade wars hit. All of a sudden, the government needed to implement these really complex new tariffs with very specific rules, percentages, and exclusions based on geopolitical logic. The rigid old ACS mainframe just couldn't do it. It wasn't designed for that level of complexity. The entire system was at a breaking point.
Rewriting the mainframe was just impossible on such short notice. So instead, engineers came up with this really ingenious workaround. Here's how it worked. The modern ACE system would spot a product that needed a new tariff and assign it a temporary Chapter 99 code. This super simple code was then passed to the old mainframe, which could easily process it and slap on the right surcharge. It was like a digital detour, a brilliant hack that allowed modern policy to run on legacy code.
But, the Chapter 99 hack couldn't last forever. It was a patch, not a long-term solution. And this brings us to the final era in our story, retiring the mainframe.
On November 4th, 2023, after 4 decades of service, the Big Iron era officially came to an end.
The ACS mainframe, that COBOL fortress that had powered the US economy for so long, finally went dark. And with the mainframe turned off, the entire US tariff system completed its migration to the cloud. This was the moment. This was when the system finally shed its 40-year-old legacy and became truly modern. And this is what it looks like today. The system runs on AWS GovCloud. It uses microservices, real-time data processing, and modern APIs. Those 3.9 million lines of COBOL, they're retired. Tariffs are no longer these hard-coded variables. They're dynamic data points in a flexible, modern environment. What a change.
So what's the big takeaway from all of this?
Well, the entire saga is a really powerful lesson in technical debt, and it tells the story of what it actually takes to upgrade a nation's core infrastructure. At the end of the day, when the trade wars hit, the US was fighting a modern economic conflict using a system designed back in the 1980s. That Chapter 99 hack was the absolutely crucial patch that kept the system alive just long enough for the full modernization to finally happen. It bought the necessary time to finally pay down decades of technical debt. From ledgers to mainframes to microservices, the code behind the tariff tells such a fascinating story of technological evolution. But it does leave us with a final and pretty important question to think about. What other critical infrastructure in our world is out there right now, just running on borrowed time, waiting for its own Chapter 99 moment?